What if I told you there's a way to solve any quadratic equation without memorizing the quadratic formula? Today, we're learning a single powerful technique that makes solving quadratics faster, easier, and gives you deeper understanding of how they work. Let's review what we typically do. We try the difference of squares pattern, check for perfect square trinomials, attempt factoring, and when those don't work, we pull out the quadratic formula. But the formula is tedious to memorize and calculate. What if one of these patterns could handle everything? Here's the secret: the perfect square pattern. X squared plus 2ax plus a squared equals x plus a all squared. This single pattern is the key to solving any quadratic equation. Let me show you why. Here's what you need to remember. Take the coefficient of x, divide it by 2, then square it. If that matches your constant term, you have a perfect square trinomial. This becomes your first habit when looking at any quadratic. Let's practice this recognition. Let's test two equations. For x squared plus 2x plus 1, we take 2, divide by 2 to get 1, and 1 squared is 1. Perfect match. So this factors as x plus 1 squared equals 0, giving us x equals -1. Second example, x squared minus 4x plus 4. We take -4, divide by 2 to get -2, and -2 squared is 4. Another match. This is x minus 2 squared, so x equals 2. But here's where it gets powerful. Most quadratics aren't perfect squares, so what do? We force them to become perfect squares. We add the term we need to create a perfect square, then subtract it to keep the equation balanced. This technique is called completing the square, and it works on absolutely any quadratic. Let's work through x squared plus 4x plus 3 equals 0. First, we figure out what we need. 4 divided by 2 is 2, and 2 squared is 4, so we need a 4 as our constant. We add 4, but to keep the equation balanced, we also subtract 4. Now we can group the first three terms as x plus 2 squared and simplify the rest to get x plus 2 squared equals 1. Now we finish by taking the square root of both sides. Remember, when you take a square root, you get plus or minus, so x plus 2 equals plus or minus 1. This gives us two solutions. X equals -2 plus 1, which is -1, and x equals -2 minus 1, which is -3. Done. No factoring guesswork, no quadratic formula. Let's try something trickier with fractions. For x squared plus 7x plus 12, we need 7 divided by 2, which is 7/2, and that squared is 49/4. We add and subtract that, create our perfect square, x plus 7/2 squared, combine the remaining terms to get -1/4, then solve. Even with fractions, the process is identical. So x plus 7/2 equals plus or minus 1/2. For the positive case, -7/2 plus 1/2 gives us -6/2, which simplifies to -3. For the negative case, -7/2 minus 1/2 is -8/2, which is -4. Our solutions are x equals -3 and x equals -4. Here's what makes this method truly universal. Whether your quadratic has two real solutions, one repeated solution, or even complex solutions with imaginary numbers, completing the square handles all of them with the exact same process. No special cases, no different formulas to remember. Let's try an irrational solution. For x squared plus 6x minus 12, we need 6 divided by 2 squared, which is 9. Complete the square to get x plus 3 squared equals 21. Taking square roots gives us x plus 3 equals plus or minus the square root of 21. So our solutions are -3 plus the square root of 21 and -3 minus the square root of 21. The method handles radicals effortlessly. Now for complex solutions. With x squared plus 2x plus 5, we need 2 divided by 2 squared, which is 1. Complete the square to get x plus 1 squared equals -4. Now we're taking the square root of a negative number, which gives us imaginary solutions. Square root of -4 is plus or minus 2i. So our solutions are -1 plus 2i and -1 minus 2i. Same exact process, different type of answer. So why is completing the square superior? First, you only master one technique instead of 3. Second, there's no trial and error like factoring. The process is algorithmic and always works. Third, you don't need to memorize the quadratic formula. Fourth, it handles every type of solution identically. And here's the kicker. This method is exactly how the quadratic formula was originally derived. You're learning the fundamental principle. Here's your new checklist for any quadratic. Step 1. Take the x coefficient and divide by 2. Step 2. Square that number. Step 3. Add it and subtract it in your equation. Step 4. Factor the first 3 terms as a perfect square. Step 5. Take square roots of both sides and solve. 5 simple steps. No memorization needed beyond the perfect square pattern. And that's it. You've now mastered completing the square. The quadratic formula, you don't need to memorize it anymore because you understand the principle that generates it. This one technique gives you power over any quadratic equation you'll encounter. Practice this method, make it automatic, and you'll solve quadratics faster than anyone reaching for the formula.